Hi, everybody. I'm Andrew Bloomgarden. Thank you for coming. I'm going to be talking today about what I've spent the last year working on with many people, the Nth Region project at New Relic. We've redesigned the infrastructure New Relic runs on to support scalably building and operating many regions. So in this talk, I'm presenting it as an open retrospective, talking both about the technical and the organizational challenges of the project and what we learned. Think of this as a case study in the way a medium-sized company deals with the challenges of operating at scale, again, both technically and organizationally. So most of you have probably heard of New Relic, and some of you are maybe even customers of ours, but let me give you a perspective of what we do from the perspective of an engineer at the company. We're an observability company that builds software that our customers use to analyze how their software actually works in the wild. That means that our customers send us a ton of data that we process and store, and then we present back to them in the form of alerts, curated UIs, and ad hoc queries, all for a variety of different products. So we have mobile agents, browser agents, agents that can be installed in JVMs. Customers send us data from all of that, and then we present it back to them so they can see how their software is actually working. And last year, as part of our partnership with IBM, we agreed to build out a region in Europe, in IBM's data centers in Frankfurt, in order to be able to let European customers keep their data in the EU. Up until this point, all data would come to the US, whether or not the company was actually in the US. And note that this isn't the same as some kind of multi-region projects where you're just building it out for redundancy. We needed data isolation as a result of this. So we signed this deal, and then engineering found out about it, and this was a pretty scary proposition, despite our fairly well-run organization. So let me explain why. So I started at New Relic 8 years ago, and we had just one app. It was great. It was the UI and the data collection tier. It was all in one. It was a Rails monolith. It did everything. It's great for local development. And then shortly after I started, one of our engineers split out the collection tier into the aptly named collector. It was written in Java, and it was a couple of orders of magnitude faster, and it was more efficient than the initial Rails implementation, which probably isn't that surprising. And if we had stopped at that point, this would have been sometime in 2010, and we said, okay, it's time to build a European region. Technically, this would have been totally fine. We could have tweaked a couple code bases, provisioned some hardware in Europe. We were running at such a small scale, no big deal. But we didn't. Instead, in those 8 years since that time, we've introduced new products and features, and we've scaled enormously. And to handle that growth, we've had to continuously re-architect our software. So today we're handling around 30 gigabits per second of traffic inbound, processing around 15 million Kafka messages per second, writing 600 million events per minute to disk. These are key value pairs that our customers send us for about a transaction in an application or a sample of a host CPU usage, that kind of thing. We have around 50 engineering teams and hundreds of engineers on those teams. And this is what our architecture looks like today. So, like most service-oriented architectures, this reflects both actual technical requirements. We've had to spin up all these products. We have to handle all this data. There's no way this could have worked on our original architecture. And it also reflects organizational structure. And our architecture is at the point where a single easily understandable diagram can't faithfully represent it in all its detail. And there's no way that our original 1 or 2 app architecture would have scaled this far, so we did make the right choice. But we never really considered that we'd ever have to run in more than one region. It was always a potential future that never seemed to arrive. It was like, okay, maybe next year we'll build a European region, but we're not going to make decisions now that is going to make that easier. We're just going to keep doing what we've been doing. So the business said, time's now, we're going to build an EU region. We knew this was going to be a really painful exercise for us. So we then, asked, okay, are you ever going to want to do this again? And they said, yeah, probably. So we changed the project. Said, okay, we're going to change this. We're going to build the Nth region. We want to make it focus on building tools for building regions so that the next time, rather than every team at the company having to make changes to their software, ideally one small team of engineers can be the ones to turn up a new region. And we were cute about this. We called this Project Backpack, as we mostly Americans were going to get on a trip to Europe. So I said that we ran in one region, but that's actually a little bit of a lie. We did have experience building new regions because every year we do a disaster recovery exercise where we prove to ourselves and to our customers, more importantly, that in the event of something terrible happening, we can rebuild the entire New Relic stack in a new environment, somewhere geographically distant, because the assumption is it's probably some kind of terrible thing happening where our data centers are. And we knew that this was really painful for us. And we did prove that in the event of a real emergency, we could drop everything and recover, but the exercise just took a lot of effort across the entire engineering organization. So when we started the EU region project, we knew that's what we'd have to look into. Why was this so painful? So in the 8 years I've been at New Relic, we've had to solve a variety of problems. We've had to figure out how to deploy many services. We support a polyglot environment. We have services written in Ruby and Java, as I mentioned. We have services written in Elixir and Go, probably a few other languages I'm not even thinking of. Teams can make that decision on their own. We have service discovery. You've got to have it for that many services. You need to have some kind of secret management system, and you need some kind of container orchestration. And now we're going to say, tack on multiple regions. Cool, we got this. Except we didn't. So earlier this year, I read a blog post from Will Larson, who's worked at Dig, Uber, and now Stripe. And he wrote about the concept of migrations. And he wrote that migrations are the only mechanism to effectively manage technical debt as your company and code grows. If you don't get effective at software and system migrations, you'll end up languishing in technical debt. And the truth is, we'd solved all these problems, but we didn't really migrate the old stuff away. So it seemed like we were really successful. We had container orchestration, we had secret management, we had all of these different things, but the reason that they seemed successful was just an artifact of our fast growth. New software, or very recently new software, would be written using the new patterns, tooling, etc., but the older software just usually didn't come along for the ride. Maybe in the event of a major incident, we would say, oh, that software hasn't really been touched in 3 years. Maybe we should make it run into container. That kind of thing would happen occasionally, but it was never a systematic effort. And the fact is that a variety of vintages might be nice in your wine cellar, but it's not what you want for managing large-scale software systems. So here are the rough vintages of New Relic, at least relevant to this project. Dating back to 2010, we had systems that were Ruby and Java applications deployed via Capistrano, 2 hosts that were managed, Capistrano to hard-coded lists of hosts deployed to systems that were managed via years of crufty Puppet code that we didn't manage well. Around 2013, which is when our service-oriented architecture push really kicked off, we were extremely early adopters of Docker because we knew that the Cap and Puppet approach wasn't going to scale for us. And that was pretty painful at the time. Docker wasn't super stable. These days it is. And there also wasn't really an orchestration tool, so we built a Capistrano-style tool to deploy Docker containers called Centurion. Around the same time, we built an in-house service discovery system, Cerveza. But anything written in the past couple of years doesn't really use this anymore because we kind of abandoned it. Dating back to 2016, secret management, we need a better solution. We're going to deploy Vault. And finally, we got our stuff together, and we're going to deploy a Mesos cluster, our container fabric project, and some much better build and deploy tools on top of that, what we call Grand Central. And so you take all of this together, and that means that a disaster recovery effort has to account for every single one of these. And every single one of the systems that are in these different buckets have to be accounted for. So what we'd seen in our DR exercises was that there was just a ton of busy work and toil involved in supporting all of these flavors. A ton of time was spent copy-pasting configuration, tweaking it for the new environment, finding out that you made a mistake, repeating it over and over, and maybe finally it'll work. And one good example of how bad this got was that we weren't comfortable merging a long-running branch to add the DR environment to our Puppet configuration, just because it got so large and complex. Our Centurion story was pretty similar. Centurion is managed via rake files, so it's Ruby, you can do anything, but mostly it looked like this hard-coded list of hosts, some environment variables, so DR is a copy, paste, and tweak. Our Cerveza system for service discovery, which was much, much better. This is code to access our feature flag system. This wouldn't have to change at all, but as I mentioned, we didn't really use this as much anymore, and so there were services that had just huge hard-coded blocks of service discovery. Let me zoom in on one. This is how one service accessed our agent databases by shard ID in the disaster recovery environment. So if you imagine that we want to support many regions, this kind of thing is not going to fly anymore. And unfortunately, while our Mesos platform was awesome and made deploying containers a lot easier, the management around it didn't really try to solve this problem either. It had blocks of configuration in YAML that you couldn't really share except if you were going to try to do some YAML sharing tricks, which typically led to incidents when you realized you did it wrong. If you copy-paste that, you do that for DR, make some tweaks, maybe it's going to work. So we knew that we'd need to figure out what are the changes that we need to make to support one team or a small number of teams building this new region. What we really needed here were just strong interfaces, both between different parts of the technical system, as well as between teams in the infrastructure. And just to reiterate, a conference like Strangeloop probably don't need to, interfaces are really valuable because they separate the contract from the implementation. So let me give an example of what putting an interface in a system can do. This is a real process at New Relic for getting database credentials. A team would say, OK, I have a new service. I want to talk to this database, or this service is now going to talk to this existing database. They would file a ticket. They would wait for the database team to get to the ticket, to add the credentials, say, to LastPass and share them, or to the database and then share them via LastPass. Then the team would receive them. They'd add them to the service configuration, and then they deploy the service. And this works okay for ongoing operations. But if you wanted to, say, repeat this entire pattern for every single service database combination we have in production for a new region, it's going to be very, very painful. So even if what you do is you say, well, we're just going to put a programmatic interface around this. There's, you say this service needs access to this database. There's a black box, and then you deploy. Even if on the inside of that, it's still manual work. The database team is adding credentials, manually sharing them, or putting them in the right place so the service can read them. The database team is then free to say, okay, cool, we can spend some time automating this, get out of the business of manually generating credentials. And the value here is that encapsulation lets small teams act independently. If we had said, okay, we need to change our human-driven process and have every team in the company have to change to correspond, that's a big project. But if we'd set up the right interface, only the database engineering team needs to care about it. So what we needed to do in this project was figure out what are those high leverage interfaces, those things that we can get every team in the company to cooperate on so that we can unlock this and future value for the company. So I'm going to go through a few things that we settled on, a bunch of work, but it's been really valuable. First, service discovery. So as I mentioned, we had our Cerveza system. It was a homegrown system that read some configuration and did dynamic service discovery. Worked pretty well. Had some problems. Also, tons of hard-coded service discovery. And more of our recent services had service discovery via environment variables where they'd find some URL or some other host name or something. But oftentimes those values are actually hard-coded as well in a configuration file. We didn't have a solution for credential management, and I don't mean where you put the credentials, but how the credentials get there in the first place. And also, we had no way to do static analysis. So I'm going to take a brief digression and talk about why static analysis is really useful when you're thinking about the problem of building out a new region or just thinking about the architecture of a system in general. So if I'm in charge of deploying a new region and I'm going to either write software to deploy services or click buttons to deploy services, and I need to deploy service Alice, it would sure be nice to know that service Alice actually depends on service Bob before I deploy it, and then suddenly it's broken. Maybe I don't even find out about this until a couple days later because the service thinks it's totally fine. Its health check isn't actually checking its dependency. This is real life. This happens. If you had static analysis, you could say, oh, well, before I deploy service Alice, I must deploy service Bob, so I'll do that, and then I deploy service Alice, and everything's great. And this is the key flaw that our Cerveza system had. Cerveza was just runtime service discovery. It could be embedded many layers deep in a library that's pulled in by a library that's pulled in by a library. Could be across repos. There's no good way for us to tell, oh, this service actually talks to this other one. Could be buried very deep. On the other hand, we did have something that, if you squinted at it, maybe could give us that information. Environment variables. Services have some configuration that say, if Alice says, I need a URL for where Bob is, if we had the right kind of inspection technology, we could look at this and say, oh, Alice actually depends on Bob, because if Alice needs this URL, they have to. Now, the reality was that we had a bunch of different formats for expressing this data. Services would take either URLs with a path or without, or a host name. But if we can put a little layer of abstraction in place here and say, OK, you, the service, are going to actually just declare that you need to know where Bob is, this discovery path syntax, and then we'll replace it at deploy time or runtime with the actual value of where Bob is, then we can solve this problem. We can figure out, oh, what services depend on each other. And this also helps us solve our credential management problem, because the classic example is databases. A service needs access to a database. That's hopefully authenticated. And our services typically took some subset of these 5 values for how to talk to a database. But those can also be passed in a URL. So we can extend our discovery path syntax to say, OK, this means an authenticated dependency. If I see an @ sign, that means I want credentials along with it in the URL. This is the service discovery as dependency injection. Services declare their dependencies. Locations are injected via environment variable in a standard format. Credentials can be part of those URLs. And most importantly, static analysis is possible. And the key here is that, again, we're not necessarily using this data at the start, but we're building the system so that we can improve operations iteratively in the future. We can pull this data out and start to do interesting things. The next thing is containers everywhere. So we've known since 2013, when we first started using Docker, that containers, most importantly, are an interface between teams and the machines that they run on. Back in the bad old days, if I wanted to deploy a new Ruby service, I needed to go tell our Puppet folks or write a Puppet PR that would say what Ruby version it's going to use, what libraries it's going to use, make sure that the OS version is compatible, and this didn't work well at all for us. So Docker solved this problem. It was great. But we had this centurion overhead of having to manually specify lists of hosts, and in the meantime, technology had progressed a ton. We had Mesos, we had Kubernetes, and we had a Mesos project in flight. So we were able to say that all of our stateful services should actually move to our container fabric cluster and just be orchestrated. And this will remove a ton of busy work both for US operations as well as for the future EU operations. And we knew the power of containers, but we didn't really, generally speaking, run our stateful services in them. But we could see where things were going. Soon enough, Kubernetes is going to be able to solve this problem for us. We're going to deploy it. But we don't want to bite that off as part of this project. But what we can do is make sure that everything is going to be in a container so that when that day comes, it's a much easier lift. And we did actually have experience running stateful services in containers. Our largest Cassandra cluster had been running in Docker since 2015, a project we called Docsandra. We had multi-tenant relational databases in Docker since last year, and my colleagues actually gave a talk at Percona Live about it earlier this year. And that also allowed us to do one more really valuable thing, which is to standardize on CoreOS, not CentOS. So CoreOS is a Linux distribution that has one job, and that job is to run containers. And it solves two related problems for us. First, the configuration service is just so much reduced compared to other Linux distributions. It doesn't even have a package manager, to the point where if you want to do anything useful, you probably want to put it in container, which is very convenient because that's what we want to see. And also, it has a first boot configuration system, Ignition, that's pretty well matched to the level of configuration that CoreOS actually supports, which means that we can safely abandon our unloved Puppet installation. That means we don't have to produce a PR that we're never going to merge. We can just say, we're done with Puppet. And that's no shame on Puppet, that's shame on our management of it. One other nice thing about Ignition is that it has, Ignition itself is a semi-human readable and questionably human writable JSON format. But it has a nice YAML layer on top of it that is human readable and writable. And it's also, the transpiler from that YAML to the JSON is available as a Go library. So we can integrate it into our machine provisioning process and actually make assertions about what's going to happen. So at New Relic, we want to run the New Relic infrastructure agent on all of our hosts. We can put that in the YAML files, and then we can write unit tests to say, just by the way, make sure that every single machine is going to get this agent on it. Finally, the last thing that we needed to do was ensure that we were using Terraform for the new environment. A lot of infrastructure is just fiddly customization. Okay, this S3 bucket needs this flag, this S3 bucket needs that flag, and that's something that we kind of managed over time, but a lot of our older buckets, honestly our more crucial buckets, were not managed via Terraform, or maybe they were managed via a CloudFormation stack that we can't touch. So using Terraform allows us to just make that repeatable. And the Terraform project and community provide a lot of off-the-shelf providers that make different cloud APIs accessible from Terraform, but you can also develop your own, and it's pretty easy. And we found that biting the bullet and developing Terraform providers to close these gaps that we encountered paid off repeatedly. To give you an example, IBM provides a Terraform provider for their infrastructure as a service, and that works pretty well. But we have a different notion of machine lifecycle that we want to impose on that. We use bare metal machines with IBM. They have a notion of a monthly billing cycle. We want to be able to provision and destroy machines between months. Okay, let's write a provider. We're going to make that happen. It's not too bad, and then we can just continuously reuse that from Terraform. Now, you may all be thinking, this is kind of sounding like a bit of a second system level of project. You started out with, okay, we need to run an EU region, and we've got service discovery containers, Terraform, for a huge system. This may sound pretty risky, and you're probably right. This was really risky. And we did try to de-risk it a little bit by choosing problems not to tackle. We didn't try to get all our stateful systems running in containers that were orchestrated by Kubernetes as part of this project. And another example is in our US region, we run hardware F5 load balancers. We can't give that to IBM to run for us, but what we can do is say, well, we're running on CoreOS, we can run CentOS containers, and that can run virtual F5 VMs. Okay, cool, let's get this to work. And that means that we don't have to deal with load balancing as part of this project. And it's important to remember that at the end of the day, if we had gone ahead with this and not made the system better, we could have ended up with just twice the ongoing operational load. And more importantly, just the same amount of time to build out a new region. And if you repeat this a few more times, we'd likely drive the company down under endless operational toil or be forced to turn down business opportunities by not building new regions at all. So, we had to just find the Goldilocks balance, choose the right work. There were things that we could have chosen not to do, but we tried to find, the right level of changes to accomplish our goal. So, with all of that said, we had an execution plan for this project. This is, purely like design. This is what we want to see. Now, here's where the rubber hits the road. How do we actually get this done? What we hoped was we would do discovery of the IBM environment, of our own systems, figure out what we needed to do. And that's basically where all the stuff I just talked about came from. Then we would document all of that and broadcast it was time to do the work. Teams would do this work in parallel. We'd do some repeated test build-outs, find problems, repeat, and finally stand up a for-real environment and leave it running. Then we'd test that, and then we'd ship it to our customers. And the hope here was that we could time box this work, keep teams' involvement relatively constrained to just a couple of milestones, containerization and one targeting testing the new region. And in between those two, we wanted to ensure that teams could and would do other things. For example, earlier this year, we shipped distributed tracing support, which required a whole lot of teams to do a whole lot of work. And if we had said, okay, all of that can't happen because Backpack, we would have been in trouble. This project would not have happened. That said, that's great and all, but I wouldn't be standing up here in front of you if the project had gone perfectly. Or, maybe I would be, but honestly, I think that would be pretty boring because none of the things we did technically are all that unusual. Maybe the service discovery thing is a little bit unusual, but, what's more interesting to me is that we made the changes at some scale. So I'm going to go over some lessons that we learned along the way and sum each one up with a set of things that we'd start, stop, and continue in future large-scale projects. And I hope that these are all lessons that can be relevant to you as you consider large-scale projects of your own. So first, quick ramp-ups. How do you prioritize the work? The Backpack project was predicated on having support from the business because we needed basically every team at the company to do work for us. So we needed that work to get on their roadmap. So let's talk about how road mapping works at New Relic. First, it's important to note that every engineering team at New Relic is autonomous. That means that they have their own roadmaps, which is set by the team and their product manager, to meet both the team's own goals as well as to meet the broader requirements of the business. Those broader requirements come from a group known as the Product Council, which every quarter or so produces a list of the top five high-priority projects in the company in order of priority. And teams are supposed to contribute to those projects if they can. And some of the projects might be something that only a single team can do. And what that means is that other teams just need to make sure that that team is not blocked, that they can get their job done. And for large projects like Backpack, it means that the work for the project preempts the rest of the team's roadmap. Now, this project actually does work, but there's a catch. What happens if a project needs resources to move forward, but the Product Council, for whatever reason, hasn't prioritized the project yet? That's what happened with Backpack. There was a month or so of delay where we thought we were ready to go, we needed teams to do work, clock was ticking, and it wasn't prioritized. And then suddenly, all of a sudden, we were prioritized. Almost all teams were knocking at our door, and like this roller coaster at California Adventure in Los Angeles, where I grew up, this roller coaster has a fast start. If you don't know what's coming, you're going to smack your head. And that's kind of what happened to us. In retrospect, this swing from no support to near total support just wasn't good for the project. We had to transition from operating relatively independently, doing all this discovery work, doing some build out in the environment, to having every team at the company knocking on our door trying to figure out what the hell they had to do. And the discovery work there was well organized. There was a process for having meetings, but even still, it left the Backpack engineering team scrambling with our sudden success in getting attention. We just weren't ready. We didn't have full documentation of what we were looking for. Service discovery tooling wasn't ready. Core tooling wasn't ready. And most importantly, we just didn't have an easily digestible philosophy of what we were actually asking people to do, how to think about the problem space we were in. If engineers had understood how we were thinking about the problem better, they could have made better decisions along the way. There would have been less thrash, and we didn't have that clearly articulated. We'd articulated it in pieces along the way, but not in one place where people could go to understand. So in the future, we're going to start preparing for what happens when a project actually gets that high priority. We're going to produce a project philosophy document, and we're going to keep it updated if things change. And we're going to continue prioritizing important work across the company, because that is useful. Relatedly, the biggest problem we ran into was that the project was rightly seen as continually moving goalposts for teams. So up front, we did specify, okay, there's going to be this containerization work, there's going to be moving to container fabric, there's going to be service discovery via environment variables, but we, the project leads, also knew that there was going to be some smaller work to come. For example, our initial instructions asked teams to make the service discovery work via URLs, in a very specified format. And we knew that the tooling would come along to make it so you could swap that out for the discovery path syntax and get the tooling to automatically inject that format for you. But we didn't really mention that. Didn't mention that was coming. We knew that teams needed to do the work, and we didn't want to say, oh, you can't get going on that until we're ready with this other thing. And we didn't really communicate pieces like that at all during the entire project, or at least in the early phases. Instead, we just talked about and tracked the big ticket items up until a small item came up. And this was intentional for a couple of reasons. First, each team has a hero role that passes around, typically via the on-call rotation. And their job is both to be on call as well to handle small requests from other teams. So we thought that the smaller stuff to come could be handled by the hero. And also, we didn't want to exhaustively list work that couldn't be done yet, especially since we didn't know precisely what that work was going to be. In retrospect, this was a mistake, most especially in not communicating that there was going to be this follow-up work at all, even if we didn't know the full extent of it. And also, the fact that the team's hero rotated meant that there were cases where we would say, hey, hero, you need to do this thing for us, and the hero would be like, wait, what? I haven't actually been doing any of the EU supporting work at all. That's a lot of context switching that's required. So that's one kind of moving goalpost, and that would have been bad enough. But there was another kind. We ran 3 test build-outs, one at the beginning of December, one in January, and one in February. And our goal when planning this was to iteratively improve the infrastructure side of the build-outs. For example, to realize that our initial network architecture was wrong, or to figure out how to provision machines better, and have the opportunity to tear the entire thing down and build it up again, which is an opportunity you usually don't get in production. So that actually happened, but the build-outs were also just repeated integration exercises, finding out exactly what didn't work together yet, and suffering through all of those problems. So the reality of a build-out was that we'd been heavily encouraging teams to do work in the US to prove out the EU work, because we made it possible there, but there were things that they couldn't find out were wrong until they actually deployed it in the EU. Then, because teams weren't finishing their work at the same time, it didn't quite line up with the build-out schedule. For many teams, their schedule would look like they'd do the work in the US, they'd realize they couldn't test it in the EU, they'd move on to something else, and then the backpack team would try to deploy their software and realize something didn't work and suddenly be knocking on the team's door saying, hey, this thing's broken. And at that point, they very well may be blocking the effort entirely. And this was made worse by our decision to have the backpack team attempt to deploy each team's software as a way of ensuring unwanted shortcuts weren't being made. But, and that worked when services didn't have problems, but if there were problems, this was a lot of thrash. And sometimes this even happened a few times for the same team, which really wasn't a pleasant experience for anyone involved. And even though in our minds here, the goalpost was always works in the EU, we didn't really make that clear, and working in the EU is just a broad definition. The team thought that they were done, and then they suddenly weren't. And if other things were changing around them, maybe they really were done and they couldn't get things, and then suddenly things started breaking. So in retrospect, we should have used some kind of steel thread effort, trying to involve a smaller number of teams earlier on to validate all the steps that went into building a new region. It probably would have eased stress, but on the other hand, it could have lengthened the overall wall clock time of the project because we could have spent time with a small number of teams and then realized, oh, we kind of missed some things, or this team over here that has a ton of work didn't get started until 3 months into the project, and the overall schedule is going to be delayed. That said, there's probably a better balance to strike than what we did. So, in the future, we're going to start with some kind of steel thread effort. We're going to be more honest and transparent, stop hiding hidden work, even if only by acknowledging that unknown future work exists. But we are going to avoid waterfall planning. For a project like this, for a large software system, there's no way we could have specified everything up front. So we do still need to be agile. We need to be able to change our minds midway through the project or realize that some other things need to happen. Next, and I know this is going to shock everyone in the room, communication is hard. So New Relic has a strong culture of internal blogging as a means of broadcasting ideas and posting updates on projects. And the idea here is that this makes communication easier. We're telling everybody what's going on. And by we, I mean everyone in the company is telling everyone what's going on. So the trouble with an internal blogging culture is there's just a lot to read and discuss. Everyone's constantly writing new posts, and it's virtually impossible to know what you as an individual should be keeping up on. So that problem of too much going on to keep up on was a problem writ large, not just in writing. Even when we started having town hall events to broadcast updates to the entire product organization, we still weren't reaching everyone. Blog posts, they don't get read. Town hall events, people don't show up. It's too early in the morning. It's too late. We have offices in Portland and Barcelona. That's a 9-hour time difference. We deployed a checklist app to try to help with the problem, checking each step of the project for each service. But if a new checkbox appears because we've added something to the project, that requires someone to notice a checkbox appearing or to read the blog post that they didn't read. We did have internal linting infrastructure, but that was out of band and not widely used and had some problems, which meant that it was mostly ignored. Teams that did use it found it somewhat useful, but this could have been a lot better. What we did realize later in the project would have helped was centralized documentation of what we wanted. We'd avoided this initially because we worried that teams would see some kind of centralized documentation, see it changing, and then get frustrated that things were changing out from under them. So we thought that some kind of blog post stream would be better, but we were wrong. What we should have had is a centralized documentation with some kind of user-readable changelog, not git commits, saying these are the things that have changed at this point in the project, so that a team that's coming into the project later can catch up, someone who went on vacation can catch up without having to catch up on 4 weeks of blog posts. So in the future, got to have that centralized documentation. Having better linting would have helped a ton. But we're going to continue to blog internally. It's really useful for engineers to know what's actually going on at the company and have a more flat organizational structure as a result of that. And we're going to continue to communicate it using as many channels as possible because we know that just one doesn't work. Next, local maximums. One consequence of our incomplete standardization was that teams were just heavily incentivized to make the system better locally. So what I mean by that is, let's take a thought exercise. Imagine that you're on a team 3 years ago at New Relic, and you manage, say, 20 services, all part of one system. And you want some things that the platform doesn't provide you. You want chain deploys from service to service or from staging to production. You want some kind of shared configuration. And you want service discovery. And so you build all of these things. And for 3 years, you get the benefit of it before the company provides them to you as part of standardized tooling. And now someone comes along and says, OK, as part of this project, we need you to start using the standardized tooling because we need you to be on our Mesos platform. And that has only one door in. It's not going to be great. You're going to have some kind of transition pain. But the promise is that after you're on standardized tooling, you're just going to be in much better shape. But the reality is that you're not really going to be. There's going to be some aspect of the standardized tooling that's almost certainly worse than what you built for yourself because it's solving a more general problem, not what you actually intended to solve. And this isn't a good way to make friends, is if there are a bunch of teams that have done this work and you're asking them to abandon their work all simultaneously, you're really not going to be able to give them an option. If you need them to do the work for the broader project, they're going to be resentful. I don't have a good answer here, but at least we can have more empathy for teams stuck in this situation. And if we communicated well in advance that this was coming, perhaps our central tooling team could have closed some of these gaps earlier. But also, I just kind of made some assumptions about how people will react. And we also have to stop doing that. Some teams may have great standardized tooling, but may be sick of maintaining it. And just having someone else to do that job for them may make them excited to move on to somebody else's problem. And we are going to continue making standardized tooling better. It's what allowed this project to work in the first place, which gets us on to my next point, leaning on what you have. Probably the best decision we made in the project planning was to piggyback on work that was already in progress. We had our Container Fabric team building our Mesos platform. We had our Build and Deploy tool team building our Grand Central Build and Deploy system. We had our database engineering team building our containerized database platform. In addition to the obvious benefit of skating where the puck is going, not trying to change the direction of the puck, this has the benefit of effectively expanding the project team to all of those teams as well. It was a bit rocky at first. We needed to make sure that everybody understood where we were going. But once everybody was on the same page, these broader project teams were able to contribute to the overall direction of the project, do some key features that allowed the project to work at all. That said, similar to the experience of the Backpack team getting prioritized by the product council, the teams running migrations already in progress suddenly saw huge upticks in adoption thanks to Backpack. This is good. They're getting more people to use their stuff. That's one of their goals. But it's also quite stressful because suddenly you have 30 teams knocking on your door saying, oh, this thing is broken. On the other hand, one of our design goals was to put the work for infrastructure improvements on a small number of teams rather than spreading it across the entire company. So in some sense, that was the right decision. So in the future, we're going to make clear which priorities are highest for infrastructure teams, and we're going to continue to look for high leverage work a small number of teams can do. Last but very much not least, the importance of a pilot phase. So I mentioned that our original plan was we were going to do discovery, we were going to fan out, test it ourselves, and then ship it to customers. But we realized that there was just no way that we could assure our customers or ourselves that this system was going to be stable when we shipped it, if we shipped it in this way. So we delayed GA significantly, opting instead to run a pilot phase for a very limited number of customers. And that allowed our teams to be on the hook for reliability without the same consequences when things inevitably went wrong. We're running on a new cloud, we're running with some new infrastructure, things are going to go wrong. We don't want that to be a very public incident that knocks out our entire European region. And this was absolutely the right decision. Just having wall clock time with real customers that expect and accept problems allowed us to experience both bugs on our side, which happened, and incidents in the underlying cloud, which also happened. We can never completely avoid problems, but at least we can practice our response, and now we're in a much better position. So here, I honestly don't know how we ever thought it was going to be okay to build out an entire region using new technology and just ship it immediately. It's kind of magical thinking. So to sum up, where are we now? First, it's most important to note that this worked. We have a European region. If you're interested in it, contact your salespeople, or contact me. We can hook you up. And we're also seeing dividends across the board. In our disaster recovery work, we saw an order of magnitude fewer engineering hours go into the project. That's huge, and it's only going to continue to improve as there are further changes we can make to make the process better. We have less busy work involved in service operations, and we've laid the groundwork for even more improvements there too. We have 95% of our services running in our container fabric. This is great. And there's a bit of a meta benefit. The more we expand our operations and stay on the bleeding edge of software and infrastructure practices, the better able we are to serve our customers doing the same. So as heavy users of New Relic ourselves, we can run into the rough edges, hopefully before our customers do, and then make the product better in advance of them running into those problems. And we learned a lot. Learned about running large-scale projects, and that's going to keep helping us as we grow. Delivering features as a small team is really fun and it's valuable. But when you can successfully coordinate a large number of teams to do a huge project like this, you can do really amazing things. So in the future, we're going to continue a little bit of magical thinking and trying some bold things. So thank you for all of you for coming, and also for all the hundreds of people who worked on this project. And also, we're hiring. Thank you.